All right, we're going to start with Unit 7. So for this first one, it wants to know which one of these could be the particular solution is y equals e to the x minus 2. So if you look here, notice how we have y prime and y. So I'm just going to make note of those. Y equals e to the x minus 2. And that would make y prime equal to just e to the x. So now I'm going to plug them in to see which one makes a true equation. So I'm just going to have to use my answer choices. So for a, I have e to the x minus e to the x minus 2. And I want that to be equal to negative 2. So if I simplify this, I can see it's going to equal to e to the x minus e to the x plus 2. So the e to the x's will cancel, but I'm left with a positive 2, not a negative 2. So notice B, that's exactly what I wanted. E to the x minus e to the x minus 2 is going to be e to the x minus e to the x plus 2, which equals 2. And that's exactly what we wanted here, so B is our answer. If you check C and D, none of those would be correct. Same thing goes for number 122. So looking at this, now I'm going to kind of work backwards though. So I'm going to plug in the second derivative and the first derivative of each of these functions. So right away, looking at these, I don't really want to do natural log, so I'm going to save that one for last. But I'm going to start by plugging in B. So the second derivative of e to the x is just e to the x plus y is e to the x. So I'd end up with 2 e to the x, and that does not equal 0. So it's not B. So for C, my first derivative would be 1. My second derivative would be 0. So 0 plus x equals x. That does not equal 0, so it's not C. Now for D, on D, I'm going to write it out. So I know y equals sine x, which makes y prime equal to cosine x, and y double prime is going to equal to negative sine x. So I don't really need y prime here. And I'm just going to add the second derivative, so negative sine x plus y, which was just sine x. And that does happen to be 0, which is what we wanted. Our answer is D. We don't even have to worry about natural log. All right, 123, we have a slope field. So they give us what our slope should be. And I'm trying to figure out which one of these could be our slope field. So the easiest way to look here, notice we have x times y. So if x times y, if either one of those values is a 0, I should have a 0 slope. So let's just check. So if I look right here, it's a 0 slope. Here it's also a 0 slope. That one's good. Here we have 0 slopes. Here we have 0 slopes. That one's good. 0 slopes. But then right here I have an undefined slope when our y value is 0. So it's actually not C. Same thing goes for D. I have a 0, but then here it's going to be undefined. So it's not D. So now I need to figure out what the difference is between A and B. So I know if my signs are the same, it's going to be a positive slope. So let's say that I plugged in the point 1, 1. So if I look at 1, 1, 1 times 1 is a positive 1. So I should have a positive slope at 1, 1. Notice on A, that's a negative slope, so it can't be A. Let's check this one. 1, 1 is a positive slope. So B is our answer. On these, you just have to plug in points to see which one matches the slope that they want to give. All right, now we have a slope field, and we want to match it to the equation. So let's first start by looking at our zeros and our undefined. So when x is 0, it should be a 0 slope. A, B, C, and D all match that. When y is 0, it should be undefined. All of those equations match that. So that doesn't help us much. Let's look at when it's positive 1, 1. So at the point 1, 1, should be a positive slope. Let's make sure all of our answer choices would give us that. And it looks like all of those pass that test. Now if I look at negative 1, 1, it's still a positive slope. So now let's check. If I plugged in negative 1, 1 to A, the x is squared, so it would be positive. That one works. If I plugged in negative 1, 1 to B, this would give me a negative. So that's not what I want. Same thing goes for C. If I plugged in negative 1, 1, it would make it negative, so it can't be C, but D is okay. Now let's look at 1, negative 1. And if I look there, that should be a negative. So if I plugged it back into A, the x squared would be a positive divided by a negative 1, so that one's negative. On D, they're both squared, so if I had 1 squared over negative 1 squared, I'd end up with a positive 1, which does not match our graph up above, so it can't be D, which means our answer is A. You just have to try a bunch of points to see which one will finally eliminate everything. Okay, 125 wants to know which one of these quadrants, so it would make it always negative. So if I look here, I have x times y squared. That means we don't care what y value we have, it's always going to be made a positive on top because it's squared. And then I have e to the power of y. So if you think about what e looks like, it looks like this. So e is never negative, so this one's always going to be positive also. So really, our y values do not matter here. It only depends on x. So let's think about our quadrants. Positive, positive, negative, positive, negative, negative, positive, negative. So if I want this entire equation to be a negative, the only way that can happen is if x is negative, which is going to happen in these two quadrants, which would be 2 and 3. The y values don't matter in this case. All right, here we have a differential equation. This is where we're going to have to use separation of variables. So I'm going to divide by y here. Then I'm going to take the antiderivative. So I have natural log of y equals 4x squared over 2, which is then just going to become 2x squared plus c. All right, then it tells us when y equals 1, x equals 2. So I can go ahead and, since I know natural log of 1 equals 0, we can actually go ahead and do this to find our c value. So natural log of 1 is 0, 2 times 2 squared, that's 2 times 4 is 8, plus c. That tells us negative 8 is c. So then I'm going to plug that back in. Natural log of y equals 2x squared minus 8. Then I'm going to e both sides. to get rid of the natural log, so I'm left with y equals e to the 2x squared minus 8. And we can see that matches A. Alright, this one we are given a differential equation and they want to know which family it belongs to. So to me, I'm just going to solve this one. So I'll get y's by themselves by dividing. So I'm left with 1 over y dy equals 1 over x dx. Take the antiderivative, which gives me natural log of y equals natural log of x plus c. Now we can't really find c here because they don't give us any initial value, but that's okay, let's just keep going. So I'm going to e both sides. So I'm left with y equals, now remember this c here is going to end up being basically a big C. And then e and natural log cancel each other out, so we're just left with c times x. So if I'm looking at y equals c times x, think about if if c is any number, we can tell that is a linear equation because there's no exponent on that x. Alright, next one is 128. Same thing here again. We're just going to separate our variables. So you should never really add or subtract here, so I'm going to divide by p minus 3. Then I take the antiderivative, so I'm left with natural log of p minus 3. And we don't have to do u sub on this because there's no coefficient on that p. And this is going to equal t plus c. And then I can go ahead and plug in, so natural log of 2 minus 3 equals 4 plus c, based on the initial condition they gave us. So this is going to end up being natural log of -1, but notice there's the absolute value there, so that just becomes 0. So 0 equals 4 plus c, -4 equals c. So then I have natural log of p minus 3 equals t plus, not c, we just found out that that was -4. And then I'll e both sides. So p minus 3 equals e to the t minus 4. And then I'm going to add 3 to both sides. So I don't know where I messed up here. There really should have been a negative out front. But still, regardless, if this ever happens, pick the answer closest. The answer is C. That's my bad. I don't know what I did. Alright, 129. Same thing here. So we're given ky. We're trying to figure out the equation. So I'm going to divide by y. Leave k over here with dx. Antiderivative. Natural log of y equals kx plus c. Alright, this time our y value is 100, and I don't know what natural log of 100 is, so I'm going to go ahead and e both sides. So I know y equals, I'm going to change this to big C, e to the power of kx. Then I can plug in my values, so I know it's 100 equals c e to the power of 0, which is 1. So I know c equals 100, so I get y equals 100 e to the power of kx. So if they ask us what y of 3 is, that just means I'm going to replace my x with 3, so y equals 100 e to the power of 3k, which makes our answer C. Alright, on 130 on my answer key, I just put a question mark, so I'm not going to embarrass myself and try to do this on this video, since this is the last problem. I'm going to try to figure it out, so if you ask me in class, hopefully I'll have the answer. But that's it for Unit 7.